Hey everyone, today we're gonna be doing a Leetcode question which is relative sort array. So in this question we are given two array 1 and array 2, and they are saying like all the elements inside the array 2 are distinct, and what we need to do, they are saying all the elements inside the array 2 are also there in array 1. So they are asking us to sort the element in the array 1 in such a relative order, every element in the array 1 should come as the element coming before, in the order of array 2. So suppose this is some example, they are saying this is a array 1 and this is array 2. So they are saying 2 should come as per the relative order of this array. So in this array, whatever elements are there, it should come in this sequence or in this index order. So 2 is coming in the 0th index. So all the 2 should come first irrespective of number. Also they are saying there will be some number missing in the array 2, but you need to place that in the last. So they are saying element that are not appeared in array 2 should place at the last of array 1 in the ascending order. So let's see how to do this with some example. So we'll take the first example, like the array 1. Okay, so we have array 1 given 2 3 1 3 2 4 6 7 9 2 and 19. So they are saying like this is one array. Also we are given one array 2. So this is array 2 and this has some element 2 1 4 3 9 and 6. Okay, so if I say the indexes of this element, this array, so if I say for this particular array, the indexes are the relative order for this one. So we need to sort this array as per this array order, or the number coming in this array in a sequence. So if I say the indexes are like this 0, 1, 2, 3, 4 and 5. So for this element, if you see, we need to sort this array. So we need to check whether this element is coming in which relative order. So 2 is coming first. Similarly, like this 2 and this 2 should come first. Okay. So as the relative order is in this array 2 is the starting one. Similarly, 2 after 2 there should be 1. So all the 1 should come second. Similarly, so what we are doing, we are checking all the elements from here. So if I say we are creating some resultant array, so this is our resultant array. So what we are doing, we are checking this particular all the element which are coming in which sequence. So if I say okay, what I'm doing, I am checking all the number. If I say this is coming in this order, so 2 should come first. So what I can do, in the first place, I can like iterate over this array and insert all the element which are coming in the sequence. So 2 is coming here, so I should place all the 2 here at first, because all the 2 should come before all the element. Or in another word, you can say if we do the sorting of this array, all the element should be sorted in this indexing order. So if I say for this 2, this and that should come first. So this will be 2. Um, so here it will be 2, 2 and 2. So we have covered all the 2's in this array. Now the 1 is coming, so we need to place all the 1's. Okay, we'll place 1. It is only there 1. Now we have what, 4. So how many times 4 is coming? Only one time. So we'll place 4 here. Now 3 is coming how many time? One time, two time. So we'll place 3 here, 2 time. Now if you see 9 is coming one time. Similarly 6 is coming one time. We have placed 9 here and 6 here. So this amount of array is sorted, but if you see, like we have covered 2 2 2 3 3 4 1 6 and 9. If you see this part, if you see here, which part, what I missed, like this particular 7 and 19 is not present in this array, so it should be coming at the last as per the question. So it will be placing like 7 and 9, and this should also be sorted as per the number. So whatever number is the smallest one, it should be coming here. So we have two options. Either we can do the counting and we can place all the number. So what we can say, like take this number, or you can say map this number. So what I can say, okay, Is this coming here? Is this coming here? Is this coming here? So whatever number is coming, I'll take that element apart from this. So what else I can say? Okay, I can change this to the set. If I say I have created this in a set, so I have created set of 2. What I can say, I can iterate to this one and I can like create a mapping of missing one. So I'll say missing numbers. Okay, so this is missing number. I'll say okay, iterate over this particular numbers, check whether it is present in the set. So if you check in the array, it will take order of n for checking, but in the set, order of like lookup, or you can say checking, is order of 1. So I have created additional set. I'll iterate over this array and see, I'll check which is not present in this array. So I'll say okay, this 7 is not present. I'll like append it here. 7 will come here. Similarly 19 will come here. Now this is a missing array. I'll sort this one using some sort function. So this is one separate case. Now whatever is remaining, like if I ignore this one, now these all elements are need to be sorted in this relative order. So what I can say, okay, I can make the frequency count. I can say okay, frequency I have 2 coming, how many times? 3 times. So I can make another dictionary. You can say some hash map or something. So I'll say 2 is marked how many times? 3 times. 1 is coming 1 time. 4 is coming 1 time. 3 is coming 2 times. 9 is coming 1 time. 6 is coming 1 time. So, okay. So we have just counted how many times this particular number is coming. Now what I can say, I can now iterate over this one. Okay, I can iterate over this array. I can append these many numbers. So 2 came how many times? 3 times. I appended 3 here. 1 came how many times? 1 time. I appended 1 over here. Similarly 4 came here, 3 came here, 3 came here, 9 came here, 6 is here. So this is one approach. This takes order of n log n for this particular sort. Similarly, order of n for storing this one, like the, if I say the space is order of n, we are, because we are storing all the number in this array. So we are using space complexity as order of n. Similarly, for sorting, we have taken the time complexity n log n, but apart from this, we are just iterating over this array again and we are just appending. So for that also we are taking n. So moreoverly, we are taking n log n. Now there is one simple approach if we use the custom sort. So if you see, there is some function in the Python. If we say I have some sort function, I have this sorted function. I can pass my array here. I can pass the key. So if you see in general, what you can do, like if I say, if you just wanted to compare, you can normally pass a key over here. If you say a simply an x, like one element come from this array and it will be doing the sorting. Okay, if you see this particular function, this take one element as a key, do the comparison with all of the element in present in the inside this array. But we need to do something else, like we need to sort as per the indexing order. So what I can say, okay, I'll create some dictionary of like key, or you can say this particular number, I can say number. So I'll create some dictionary of number comma indexes. So I'll mark the indexes as the value. I'll create the indexes value, and what I can do, I can use some functions over here. So what I will be passing, like in this particular function, normal key, I can pass only one argument. If I wanted to pass two argument, like I will be comparing two element at a time. So what I can say, okay, just do one thing, use some compare to key function where you can pass two element x, y something, and you will be comparing both the element. So suppose this element is present, it will be swapping, like I'll say, okay, this element came, which index is 0, okay, you come first. So it will be taking all the two elements, it will be taking one element from here, one from here, it will be comparing in this one. What is your relative order as per the indexes? So 2 come first, 2 will be placed over here. So it will be doing the in place sorting, like we are not required to create this additional array if we use the sorted function. So what I will do, I'll simply write the code here. So I'll let you know like how and what we can do. So simply like we'll do some rank, like you can, what I can say, like we are just creating a relative order. So I have some number, I will be marking its index as a key value. So number is a key and indexes is a value for what? For all the numbers, you can say for indexes and numbers in this enumerate. I'll just simply use enumerate function to get the indexes and the value. So I'll use enumerate wait, and I will be passing what? I will be creating the array 2. So I just need to find the occurrences, you can say mapping of like in the element 2, array 2, what is the order they are coming. So I just marking their indexes as the relative order. Now what I need to do, I need some comparison function. So I'll say, okay, I am like creating some function. I'll say comparator, and this is a comparator function. It will be accepting two parameters, x and y, or you can say a b c d something. So now let me show you one more thing. So if I say here, suppose I have two elements, this is one array, okay, 1 2 and 3. Every time when I use this function def compare, it will be passed using a key parameters like compare to key something, and it will be passing every time two arguments like x and y. So if you wanted to do something is as per this function, there is like a feature, you can say, when we do this comparison every time, the internal compiler, how they sort the element, they use some property like if I say I have two element a equals to 2 and b equals to 3. So if I say, okay, if I need to do the sorting in the you can say ascending order. So how the internal compiler do sorting, like for doing the sorting in ascending order, I need to return -1. Okay, so suppose I have this one. So internally it will be working like it will be passing two parameters a and b. If it will be checking, okay, if a is less than b, I'll return what? -1. If a is greater than b, it will be returning what? +1. Okay, this is +1, or let it be 1 alone. Okay, it will return 1. Else, if both the values are equal, it will be returning 0. So what I can say in short, I can return simply what? A minus b. So suppose if a is less than b, it will be returning what? Negative value. Negative means it should be placed in the ascending order. If it is returning some positive value, it means it should be in the decrement, you can say in the like largest to smallest in a decrement order. So internal, you can say compile this internal sorting works like if you pass two argument a and b, if you want this a should come first, a should come first. If a is the first argument, then b. If you want a to come first, you need to pass -1. If you want b to come first, you need to pass +1. So you are just doing like in the less than order, you need -1. In the decrement order, you need +1. So let me write the code. You will get easily like what I'm trying to say. So I have some comparator function. What I will be checking, I'll use something like I'll just simply return a sorted array. I'll say, okay, this is a sorted array. I will be passing my array 1, which need to be sorted, and the key I will be passing this comparison to. I'll just compare to key function, and I will be passing my comparator function over here. So this is my comparator function. Okay, now in the comparator function, I will be receiving two elements from the array. I will be checking its rank. So first of all, they are saying like here, if what happen is the element is not there in the array 2. In this case, like if I check this one, it will give me some index error because I don't have that element, I don't have that indexes. So what I'll say, okay, if I'll just simply check if both the element or one of the element is not present. For the safer side, I'll say, okay, if everything is fine, I need to return the rank minus, you can say, indexes. Which index is coming first? So if the indexes of x is coming first or indexes of y is coming first. If it is giving the negative, means x is coming first. If it is giving positive, then means y is coming first. So what is this? And rank? Rank is like storing the indexes of these numbers. So 2 have 0 index, 1 has 1 index, 4 has 2 index, so it will be returning the difference. If it is negative, means x is coming first as per the indexing order. Now it is for the safer side, like if we have both x and y in the our like array 2. What if it don't have any of them. So I'll say okay, if x is not in what if x not in rank, or y not in rank. If any of not there in the rank, I'll say okay, if x in rank means I have the element x. If I have x, it should return -1 because I need my x to be coming first. If it has y, see, I'm checking if any of them is not there. So if both are not there, at last they will be doing the comparison based on the number. So which number is smaller, it will be returning like this. If any of them is not present, so the next one will be there. So if x is there, y will not be there. If y is there, x not is there. And if both are not there in the array 2, it will be returning as their original number. So it is not the relative order. It is like doing the comparison on this 19th and 7th. So whichever is small will come first. So I'll say okay, y is not there in rank. So it will return what? +1, because I need to place the y and the last, because this y is the largest one. If I need this to be placed first, it should be in a positive way, because we are checking okay, first element is smaller, return -1. If the second one is smaller, return +1, because we need the opposite. We don't need to place this in the ascending order, we need to place this in the descending order. So I'll do comparison. Okay, this is fine, this is also fine. Now what I'll say, okay, I've written the code. I'll just simply compile and I'll check whether this is working fine or not. So if you see, this is taking some time and it is saying okay, rank or y x not in rank, and or y, okay, I missed in not in rank. Okay, one more thing. So one more, yeah. So I'm checking if any of them is not there. It is working fine. I'll simply submit. So what we have done, like we have checked the rank based on their indexes, and we have done the comparison using compare to key function, and this is we call like custom sort, and we are doing it in place. So I uses the sorted function because I just wanted to return. We can normally use the sort function. You can say like I'll check whether it is working fine or not. So I'll say okay, array1 dot sort, and we can pass this in the same key. So I'll pass this as a key, okay, and I'll simply return array1. So we have sorted the array1 and we are just returning that. So I'm not sure whether it will be working fine or not. So let me compile. Let me see whether it is working fine or not. So we are doing this like sorting in place. So this is also working fine. So we are not creating any additional memory for this one. There is some memory created for creating the relative order, which we have created over here. So this also work fine. And yeah, that's all for today's. Thanks for watching.